Data cleaning is the process of transforming raw or messy data into reliable data that can be properly analyzed. Now, this transformation process entails identifying incomplete, inaccurate, and improbable data points and resolving data inconsistencies or errors, as well as renaming variable names to make them more clear and easier to manipulate. While data cleaning tasks are often tedious and time-consuming, it is an essential step in the overall process of data analysis. In this lesson, we will begin to look at data cleaning pipelines in R. Now, the steps covered here are unlikely to be exactly what is needed for your own datasets, but they will certainly be a good starting point. With that being said, let's get started. On your screen, you're going to see a list of learning objectives. If you like, you can pause the video and read through it. However, we will go over them at the end. Before getting started, let's first load the packages that will be required for this lesson. So here, with Pacman and pload, we're going to load in the VizDat package, inspectdf, GTSummary, and last but not least, the tidyverse. After that, we can load in our dataset. Now, the primary dataset we will be using in this lesson is from a study conducted in 3 healthcare centers in Mozambique. Now, the study investigated individual factors associated with time to non-adherence to HIV care and treatment services. Let's go ahead and load in our dataset with the readCSV function. So here we see that we have 1,413 rows and 15 columns. Now, the first step of data cleaning will be to explore this dataset that we just loaded in order to identify potential issues that warrant cleaning. And this preliminary step is sometimes called data exploratory analysis, or EDA. From here, we're going to take a look at a few simple EDA commands in R that will help you identify possible data errors and inconsistencies. The VizDat function from the VizDat package is a wonderful way to quickly visualize data types and missing values in a dataset. It creates a plot that shows a zoomed out spreadsheet view of your data frame, wherein each row in the data frame is represented by a single line on the plot. To see what this looks like, we can try it out with a small mock dataset to first get an idea of how it works. Here, we've created a data frame of 8 patients, patients 1 through 8, and their COVID-19 diagnosis and recovery information. And as you see below, some patients have missing information represented as NA. For example, patient 4 has missing information for exposure, as well as patient 1 and 7, and patient 6 has missing information on the COVID strain. So if we run that, we have the following table, which represents the mock dataset that we've created up above. With that mock dataset that we just created, we can use the VizDat function to get a visual representation of the data types and missing values of the COVID PAT mock dataset that we created up above here. So when we run that, we get the following output, and this looks great. Each row in our data frame is represented by a single line on the plot, and different colors are used to illustrate the characters, which are, in this case, colored pink, numeric variables colored blue, as well as missing values that are indicated with the gray color. From this plot, we can tell that quite a few patients in our datasets are missing data for the exposure variable. Now we can turn back to our real-world dataset, which is much larger and messier. Large real-world datasets may exhibit intricate patterns in the data that are difficult to spot without visualization. And as a reminder, let's rerun our non-adherence dataset from Mozambique. And we have the following output. Once again, we have a total of 1,413 rows and 15 columns. And again, large real-world datasets may exhibit intricate patterns in the data that are difficult to spot without visualizations, so using functions such as the VisDat function can be particularly useful. Within our VisDat function, we're going to input our non-adherence dataset to be able to visualize any intricate patterns that may be going on. And so we have this following output. From here, we can already see some problems. There seems to be a completely empty column in the data, which is fully gray, and several variables have a lot of missing values, such as education, BMI initiation art, and CD4 initiation art. Furthermore, the names of some variables are unclear or unclean. For example, age at art initiation and WHO status at art initiation have white spaces in their names, and civil status as well as regimen 1 have special characters such as periods within the variable name. In the next lesson, we will try to remedy these and other issues as best as possible during the data cleaning process. But for now, the goal is that we understand the functions used to identify these issues. Now that we have a solid grasp on how to visualize missing data with the VisDat function, let's try to take a look at another package and function that can help us generate summary statistics of our variables. At this point, it's time for our first practice question. Now, the following data set that you see here was adapted from a study that invested missing opportunities for HIV testing among patients newly presenting for HIV care at a Swiss university hospital. Using the VisDat function that we just learned, please get a visual representation of the data and explain what potential issues you can spot based on your output. Take a moment to pause your screen and input your answer in your own RMD file. Next, let's see how to use the InspectDF package to get rich plots that summarize our variables. If you run the InspectCat function on a data object, such as if we do so with our COVID PAT mock dataset, you're going to get a tabular summary of the categorical variables in the dataset. Now, the important information is hidden in the levels column. We look at it in the output, since R has once again chosen to abbreviate our output here. We can see in the levels column, it's listed as Thibault. So it's not quite clear what is happening, even though we've said that the important information is hidden in the levels column. Well, the magic happens when you run the showPlot function alongside the InspectCat function. If we go ahead and do that, so within InspectCat, we're going to write in our COVID PAT data frame. And we're just going to directly pipe that into the showPlot function in order to visualize categorical distributions. And we have this following output, which looks great. So once again, you have a nice summary figure showing the distribution of categorical variables. Now that we've seen how the InspectCat function works alongside the showPlot function with our mock dataset, let's try it out now on our non-adherence dataset, aka our real-world dataset. To do that, in our InspectCat function, we're just going to change the data frame from COVID PAT, our mock dataset, to our non-adherence real-world dataset. Once again, directly piping that into the showPlot function. And we have this output. And from here, we can observe some issues with a few categorical variables. For example, the variable level under 35 is capitalized, as you see here. However, the over 35 label is not. And it could be worth standardizing this. Furthermore, the variable sex has levels F and male. Similarly, this too could be worth standardizing. And finally, as we've previously seen, NA is completely empty. At this point, it's time for our third practice question. So using the concepts that we have just learned, we would like you to complete the following code to obtain a visual summary of the categorical variables in the MIST OPS dataset. Take your time and input your answer in your own RMD file. Now going back to visualizing summary statistics, let's go ahead and talk about the inspect num function. So similar to the inspect cat function, you can obtain a summary plot for the numerical variables in the dataset with inspect num. So let's go ahead and run this on our non-adherence dataset directly. Non-adherence. And we're going to pipe that into show plot in order to get our visualizations. And from this output, you can notice that many variables, which should be factor variables, are coded as numeric. In fact, the only true numeric variables you see in this output are age at art initiation, BMI initiation art, CD4 initiation art, and number of pills per day. We will eventually learn how to fix these issues in the next lessons when we move on to data cleaning. But for now, let's take this opportunity for another practice question. So using the inspect num function that we've just learned, we would like you to create histograms of your numeric variables in the MIST OPS dataset. Take your time, pause your screen, and indicate your answer in your own RMD file. While the inspect cat function is useful for a graphical overview of categorical variables, it doesn't provide frequency counts or percentages for the various levels. For this, the table summary function from the GT summary package is particularly helpful. To do that, within our table summary function from the GT summary package, we're going to input our non-adherence data frame and pipe that into the asTibble function in order to see a snapshot of our output. And so we have this tibble, which is particularly long. So later on, we're going to show you a small picture of an important part of your dataset that we would like for you to pay attention to. However, feel free to explore the whole output as you code along at home. But right now, from here, you can see that the output summarizes the frequency and percentages for categorical variables, as well as the median and interquartile range for numeric variables. And just go ahead and identify some categorical and numeric variables on your own at home in order to visualize these frequency percentages and median and IQR numbers if you're unable to identify them right now. And as we said, we will be showing a photo of part of the output that you see here, where we can see additional issues with our data that wasn't clear using the inspect cat function that we saw earlier. Now, seeing this short snippet of our output, we see that some values from our occupation variable are capitalized, such as professor, whereas others are in lowercase. So this means that R doesn't recognize them as being the same value, which could be problematic during analysis. At this point, let's take the opportunity for another practice question. Using the table summary function to output a summary of your MIST OPS dataset, please identify any additional data issues. Take a moment to look through your MIST OPS dataset and input your answers in your own RMD file. Now, let's go over our learning objectives. You should now know how to diagnose dataset issues with functions such as visdat from the visdat package, inspect_cat, and inspect_num from the inspect_df package, and tibble summary from the GT summary package. And thus, by familiarizing ourselves with the data, we have been able to identify potential issues that may need to be addressed before the data analysis process. And as we have seen, the actual code needed to carry out this data exploration is indeed very little. Other R developers have already done the bulk of the work for us by creating these beautiful packages to enable us to visualize our data in a quick manner to identify potential issues. Moving forward, we're going to learn how to tackle the issues we've identified one by one. But for now, that's it for today. Thank you for watching, and we'll see you in the next lesson.